Dear friends, welcome back to my YouTube channel. This is an online chemistry tutorial. You get my previous videos from my personal home page or from my YouTube channel. And in this lecture series, we are going to discuss with you some topic in organic chemistry, chemistry of functional group. We will be focusing on functional group like alcohol and alkyl halide and phenol. And in this first lecture series, we will be discussing alkyl halide, this preparation methods. And learning objectives of this lecture series, this first lecture is to understand the preparation methods of alkyl halide from alkane and alkene. And we will learn two named reaction, Wurtz reaction and Fittig reaction. Introduction. Alkyl halides, the halogen substituted organic compounds are widespread throughout the nature. Around 5,000 organohalides have been found in algae and various other marine organisms. And halogen compounds have many industrial applications too. For example, trichloroethylene can be used as a solvent in industries, and halogen can be used as an inhaled anesthetic, and dichloro-difluoroethane used as a refrigerant, and bromomethane as a fumigant, and this is a pesticide, halogen-based pesticide, that is DDT. And there are many industrially useful alkyl halides. Coming to the structure, halogen attached to an sp3 hybridized carbon atom, hence the structure is tetrahedral. And halogen atom is more electronegative than carbon. So carbon-halogen bond, this bond is polarized. And carbon get partial positive charge and halogen get partial negative charge because this is more electronegative. For example, methyl fluoride. And this is the electrostatic potential diagram of methyl fluoride. And fluoride, the red means this part is having high electron density. That is, of course, fluorine will be having high electron density. The blue means this is having less electron density. Next one, classification of alkyl halide, halogen compound, halogen compound can be classified into alkyl halides when halogen attached to an sp3 hybridized carbon atom. For example, this one, chloroform, freon, 1,1 trichloroethane. Vinyl halide, halogen attached to an sp2 hybridized carbon atom of alkene, vinyl chloride. And aryl halide, halogen attached to sp2 hybridized carbon atom of aromatic compound, that is this one, chlorobenzene. And another classification of alkyl halides. Alkyl halide can be classified into primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. What is meant by primary alkyl halide? When carbon-bearing halogen is attached to one carbon, that is carbon-bearing halogen, this one. If it attached to one carbon, it is called primary alkyl halide. For example, ethyl halide. Secondary means the carbon-bearing halogen. This carbon is attached to two carbon atom, it is secondary, isopropyl halide. And tertiary means the carbon-bearing halogen attached to three carbon, 1, 2, 3. It is called tertiary. Next one, nomenclature. You already know how to name alkyl halide. First, you have to find the longest chain, that is we called parent chain. And if there is a double or triple bond present, you should include that double or triple bond in parent chain. And the numbering of carbon atoms should started in such a way that the substituent get lowest number. That is, you have to start numbering from this end, not from this end. Because here, if you start from this end, the substituent get lowest number. Okay, so what is the name of this compound? So you have first decide which is parachain, this is parachain, then number it, then find out the substituent, then you have to name substituent first. The substituent, the naming or order of naming should be based on alphabetic order. Okay. So this is actually 5-bromo 2,4-dimethyl heptane. Okay, next one. In this compound, this is the parent chain. The number should start from this end because the substituent gets lowest number here. And next one, what are the substituents? There are bromo, chloro, and methane. Then you should follow alphabetic order for the substituent. So 1-bromo 3-chloro 4-methyl pentane. That is about nomenclature. Next one, preparation method. Preparation of alkyl halide. First one from alkane. Hydrocarbon from alkane, you are making it. So hydrocarbon, carbon and hydrogen having approximately same electron negativity. So there is no significant charge differences between them. Then it cannot attract nucleophile or electrophile. Then it is highly unreactive. That is why it is called paraffin. Paraffin means little affinity in Latin. And so, in order to halogenate it, it requires high temperature or light. So from alkane, you need to halogenate, you need either UV light or heat. For example, methane reacts with chlorine in presence of heat or light, it gives methyl chloride. And ethane in presence of heat or light, it gives brominated to give ethyl bromine. Next one, the mechanism of this reaction, and it's a free radical mechanism, consists of 3 steps: initiation step, propagation step, and termination step. First we will discuss initiation step. And usually high temperature or light will supply the energy to break chlorine sigma bond. So in presence of heat or light, it undergoes homolytic cleavage. Usually the products of homolytic cleavage is free radicals. Free radicals are formed. So this sigma bonded electron to bonded electron break and it gives it to chlorine atom, each chlorine atom, and it contains 7 electrons. And if it is bromine, bromine is also having 7 electrons. And these free radicals are highly reactive because it wants to acquire 1 electron to complete octet. So next step, what happens is this propagation step occurs. Chlorine radical abstract a hydrogen from another molecule of methane. So that is the first step. This chlorine radical abstract this hydrogen and create another radical, methyl radical, right? Plus HCl. Then this methyl radical is highly reactive. It also needs to complete octet. And it reacts with the chlorine atom to generate the product and a chlorine radical. So you have a alkane chlorine radical here. So it can help to propagate this reaction. Then it continues the chain. So this propagation stops when termination occurs. Termination step means the combination of any 2 free radicals is the termination step. It decreases the number of free radicals and reaction stops when relatively few reactants are there. And any 2 free radicals can recombine to give neutral molecule. For example, methyl radical and chlorine radical can recombine to give this one. Chlorine can recombine and the methyl, 2-methyl can combine to give ethane. So this is the mechanism of free radical halogenation. And another example, when you react butane with chlorine in presence of heat or light, you have a possibility of getting 1 chlorobutane and 2 chlorobutane. Actually, we expected 60% percentage of 1 chlorobutane and 40% of 2 chlorobutane. But experimentally it was found that the 1 chlorobutane was 29 and the 2 chlorobutane was 71. Why we are expecting 61 chlorobutane and 42 chlorobutane? Because it is a probability or statistics, because this butane contains 6 primary hydrogen atoms and 4 secondary hydrogen atoms. So probability of finding or probability of formation of radicals are in this ratio. There are 6 hydrogen atom and 4 secondary hydrogen atom. But experimental evidence clearly telling it is something different. So what is the reason for that? The rate determining step is actually radical abstraction. That is, once chlorine radical is formed in propagation, chlorine abstract a proton. It can abstract a secondary or primary proton. So which is easier to abstract? It is easier to abstract secondary hydrogen atom than primary. Do you know the reason? We already studied the stability of alkyl radical is in this order. Tertiary radical is more stable than secondary, which is more stable than primary, which is more stable than methyl. So in this is the order of free radical. Okay, and in this reaction, butane it reacts with chlorine radical. It forms secondary free radical and primary. So this secondary is more stable. So chlorine, the product distribution, the more product will be secondary or 2 chlorobutane. Next one, preparation of alkyl halide from alkene. So this is the electrophilic addition of hydrogen halide to the alkane. And the reaction is done either in pure reagent without solvent or in solvent acetic acid. The order of reactivity of hydrogen halide is like this. HA is more reactive than HBr, which is more reactive than HCl, which is more reactive than HF. This is based on acidity order. So alkene with the hydrogen halide, either of this, you get alkyl halide. For example, ethene with HCl, you get ethyl chloride. And in this particular case, hydrogen can go to this carbon atom or to this carbon atom, whichever is the no problem, you get the same product. But when you use this compound propene, there are possibility of getting 2 products, because this hydrogen can go to either this carbon atom or to this carbon atom. When it goes to the primary carbon atom, you get 2 bromopropane. When H plus goes to the secondary carbon atom, you have a possibility of getting 1 bromopropane. But it was observed that there is only one product. So this reaction is regioselective. Another example, this particular alkene with HBr, only one product was observed, that is this double bond or H plus added to this carbon atom, not to this carbon atom. Okay, let's see the mechanism. What is the reason for that? This orientation of HBr to the alkene. So what happens first? In first step in mechanism, this alkene reacts with HBr, and this is nucleophilic, this double bond, and this H plus is electrophilic. Then this nucleophile attack this H plus. So there is a possibility of addition of H plus to the secondary carbon atom, this one. You get a carbocation, tertiary carbocation. And another possibility is addition of H plus to the tertiary carbon atom, that is this carbon atom, you get a secondary carbocation. So the intermediate stability is important. The stability order of intermediate is tertiary is more stable than secondary, which is more stable than primary, which is more stable than methyl carbon. So an electrophile adds to a double bond to give most stable carbocation intermediate. Okay, that is why you are not getting this product. Here you have a tertiary carbocation that will be more stable. So the next step is the addition of nucleophile to this carbocation and form the product. So this orientation was observed by Russian chemist Vladimir Markovnikov. First showed the orientation addition of HBr to alkene in 1869, and he said the addition of proton acid to a double bond of alkene results in a product with acid proton bonded to the carbon atom that already holds the greater number of hydrogen atoms. So hydrogen get added to the carbon atom where the carbon having more number of hydrogen atom. So in this particular example, this carbon having one carbon hydrogen atom, there is no hydrogen here. So positive part goes to the carbon having more number of hydrogen atom. It goes here, not here. That is Markovnikov Rule. Next example, this alkene, this cyclohexene, added to the HBr in such a way by governing by the addition governed by Markovnikov Rule. So here hydrogen goes to the carbon having more number of hydrogen atom, that is this carbon atom, not this one. Okay, so it form a tertiary carbocation and form product like this. So hydrogen cannot goes to this carbon atom. So this secondary is less stable. So electrophilic addition to alkane, electrophile adds such a way to generate the most stable intermediate. And you have an assignment. You can predict the product of the following reaction. Next one, preparation of alkyl halide, some named reaction like Wurtz reaction. Alkyl halide when heated with sodium metal in either solution give rise to higher alkyl. The reaction is best with primary alkyl halide. Okay, the alkyl halide, two equivalent of alkyl halide with two equivalent of sodium, you get higher alkane. What is the mechanism of this reaction? There are two possible mechanisms. One mechanism here, alkyl halide, this one electron from metal transfer to the halogen atom. Here the bond break and X, that is halogen, get one electron from metal and it form a radical, R radical and X radical, and X get one electron from metal. So it form a complex like this. Okay, and next one, this alkyl radical accept one electron from another metal and it form a carbanion, R minus and M plus. And third step, this carbanion can replace this X by nucleophilic substitution. This can act as a nucleophile. This can attack another molecule of alkyl halide by expelling this halogen. This is a nucleophilic SN2 reaction. So it displaces halide of another alkyl halide by SN2 reactions and you get higher alkane. And the Wurtz reaction, example for a Wurtz reaction is methyl bromide. It gives higher alkane ethane, and if you use ethyl iodide, you get higher alkane, that's butane. And the Fittig reaction is just similar to Wurtz reaction, and aryl halide when heated with sodium metal in either solution give rise to higher aromatic hydrocarbon. That is bromobenzene with sodium, it gives biphene. This is Fittig reaction. So in summary, we have learned in this lecture preparation of alkyl halide from alkane, and the free radical mechanism, and preparation from alkene, and we have learned electrophilic addition mechanism and Markovnikov Rule. Also we learned two named reaction, Wurtz reaction and Fittig reaction. That's all. Thank you for watching.